Welcome back to Crushing Design Patterns in .NET. In our first episode, we laid the foundation with the solid principles. If you missed that, I highly recommend watching it first. Today, we are building on that foundation to tackle one of the most useful behavioral patterns you'll ever encounter in an interview, the strategy pattern. We have a real-world scenario that starts simple but can quickly become a mess. Let's see how our expert Arohi uses the strategy pattern to keep it clean, scalable, and professional. Arohi, welcome back. Today's scenario is for an e-commerce application. We need to implement a shipping cost calculator. The business has several shipping providers, FedEx, UPS, and a local postal service, and each one calculates its shipping cost using a completely different algorithm. How would you approach this? What is the initial naive approach that many developers might take, and what are its problems?
That's a great starting point. The most common but problematic approach would be to have a single shipping cost calculator class with a large calculate method that uses a big if-else block or a switch statement to handle the different providers.
And what's the danger with this design?
This design is a maintenance nightmare. It violates the open/closed principle. Every time the business wants to add a new shipping provider, or if an existing provider's complex logic changes, we have to come back and modify the same ever-growing method. It becomes fragile, hard to read, and difficult to test.
So, how does the strategy pattern provide a more elegant solution?
The strategy pattern is the perfect solution here. The core idea is to define a family of algorithms, encapsulate each one into its own separate class, and make them interchangeable. This allows the algorithm to vary independently from the client that uses it.
What is the first step to implementing this? How do you define that family of algorithms?
The first step is always to define an abstraction, a common interface that all our different algorithms will implement. I'll create an IShippingStrategy interface with a single method, calculate cost. This interface is the contract. It guarantees that any shipping strategy we create will have a method to calculate the cost, even if how it does so is completely different.
And how do you create the individual encapsulated algorithms?
Now we create our concrete strategies. Each shipping provider's logic gets its own class that implements our IShippingStrategy interface. The beauty here is that each class has a single responsibility. If FedEx changes its pricing model, the FedEx shipping strategy class is the only file we need to touch.
Now that we have the strategies, how does the main context class use them?
The context is the class that will use a strategy. In our case, this is our shipping cost calculator. Instead of containing the if-else logic itself, it will now hold a reference to an iShipping strategy and delegate the calculation to it. Notice the shipping cost calculator has no idea what the algorithm is. It just knows it has a strategy object, and it tells that object to do the work.
How would the client code select and use a specific strategy at runtime?
This is where the flexibility comes in. The client code is responsible for choosing the right strategy and passing it to the calculator. For example, based on the user's selection on the checkout page, we can switch out the entire calculation algorithm at runtime just by passing in a different object.
What are the main benefits of using the strategy pattern here?
There are three huge benefits. First, it respects the open/closed principle. We can add new shipping providers without ever modifying the shipping cost calculator. Second, it respects the single responsibility principle. Each strategy class has only one job. And third, it makes our code incredibly testable. I can now write a separate unit test for each individual shipping strategy in complete isolation.
For an advanced follow-up, how would you avoid the client having to use new to create strategy instances?
That's a great senior-level question. Manually creating instances with new can tightly couple the client to the concrete strategies. A more advanced approach is to use a strategy factory. This is a separate class whose only job is to provide the correct strategy instance based on some input, like an enum or a string. The client code then just asks the factory for the right strategy, completely decoupling it from the concrete implementations.
Can these strategy objects be managed by the dependency injection container?
Absolutely, and that's often the best approach in a modern .NET Core application. I would register all my strategies in program.cs with a common key, or just as a collection of IShippingStrategy. Then, I could inject an IEnumerable into my factory or service and use link to find the correct one at runtime. This makes the system even more plug-and-play.
What is a common mistake to avoid when implementing the strategy pattern?
A common mistake is over-engineering. If you only have two simple, stable options, a simple if statement might actually be more readable. The strategy pattern truly shines when you have a family of algorithms that are complex, likely to change, or when you know you will be adding more in the future. The key is to apply it when you need true runtime flexibility and adherence to the open/closed principle.
Arohi, that was a fantastic practical demonstration of the strategy pattern. You've shown us how to turn a fragile switch statement into a clean, scalable, and professional design. If you're ready to apply the strategy pattern in your own projects, give this video a like and comment below with a scenario where you've used it before. And don't forget to subscribe to the .NET Way so you don't miss the next episode. In episode 3 of our Crushing Design Pattern series, we will explore how to let objects communicate without being tightly coupled as we dive into the observer pattern. Thanks for watching. We'll see you in the next episode.